There we go. Okay, so we have two ways of writing the concentration C of X or square brackets X. Two ways of saying the concentration in moles per liter, either molar concentration or molarity. Capital M means moles per liter. How is it pronounced? It's pronounced molar. Those are probably the hardest things about molarity, is just remembering all of that new sort of vocabulary and notation, because the math is really easy. All right, what are our 5 conversion factors related to the mole? What's one of them? The particle ratio. A second one, mole ratio. A third one, molar mass. A fourth one, Avogadro's number. And finally, there's a last one that we learned about last day, and that is molarity, which is the moles per liter. Which of those two are the same as each other? The particle ratio and the mole ratio are the same. Just one needs the word mole in it and the other doesn't. But you find both of them from the chemical formula, okay? If we have the particle ratio, what are we converting? We are converting from number of particles of A into the number of particles of B. If we have the mole ratio, we're converting from the moles of A into the moles of B. If we have molar mass, what are we converting? Yeah, we're converting grams of A into moles of A, or vice versa. And Avogadro's number? The number of particles of A into the number of moles of A. Now, finally, our last one here, we can use this to convert between moles and liters. So that's moles of A. We can convert that into liters of solution. And the reason I'm writing liters of solution is that soon we will learn something that allows us to convert from moles of a gas to liters of a gas, and that will be a different conversion factor. Which of these 4 will be on your quiz tomorrow? The top 4, okay, numbers 1 through 4 are on tomorrow's quiz. I would like you to see if you can remember The diatomic elements. Feel free to pull out your periodic table. Nitrogen, oxygen, fluorine, bromine, iodine, and hydrogen. Okay? All of those are diatomic in their elemental state. Elemental state means they're not part of a compound. Are they diatomic in compounds? No. So for example, sodium chloride is not NaCl2, right? So a question you might get, this is also going to be on tomorrow's quiz. We might have, for example, how many oxygen atoms are present in 8.4 grams of elemental oxygen? We're not actually going to solve this question, we're just going to make the map for it, okay? So we're going to do our map. What are we starting with? What is our initial quantity in this question? 8.4 grams of elemental oxygen. So even if it just said oxygen, unless it says oxygen atoms, you can assume that we mean O2, okay? Okay, so we are starting with 8.4 grams of O2. And our four conversion factors that we have are, we have Avogadro's number, we have the particle ratio, we have the mole ratio, and we have the molar mass. We're starting with 8.4 grams of O2. What can we convert that into? We can convert that into moles. And which conversion factor would we use for that? Molar mass. We can convert that into moles. Moles of what? moles of O2, okay? And in order to do that, we will use the molar mass. Of O2. Now, eventually, we want at the end of this whole process to get to, what's the unknown in this question? How many oxygen atoms? So at the end of this whole process, we want the number of oxygen atoms. Now there's actually two different pathways we could take. The first step is always going to be the same, but we could do something different there. So see if you can come up with one thing that we could do. And I'm gonna, while you're doing that, I'm gonna rewrite this again down below so we can do the other pathway also. What could we convert moles of O2 into that would get us closer to the number of O atoms? We could use Avogadro's number, yes. And we could convert, what would Avogadro's number convert moles into? The number of particles. So that would be the number of what? O2 molecules. Yes, because we're taking moles of O2 and converting it to the number of O2 molecules. Once we have the number of O2 molecules, what conversion factor would we use to go to the number of O atoms? The particle ratio. There is another option here for what to convert moles of O2 into to get us closer to the number of O atoms. Anyone got a guess as to what we could convert it into? We can use the mole ratio to convert from moles of O2 to moles of O. Okay, so that would use the mole ratio. And then once we have the moles of O, we could use Avogadro's number to go to the number of particles. Does it matter if you can do both of these? No, you can use whichever one you want. So if you're like, I only get the first method, that's okay. You don't need to be able to do both. Okay, but you could go either way and it would be completely correct, no matter which way you choose. Okay, is good? All right, we are going to go to 5.3b, which I think is page 59. I could be wrong, but let's see. 5.3b, page 59. Now, if we're going to be using molarity as a conversion factor, it's not very useful to have molarity written as capital M because every conversion factor needs to have two units. It needs to have a unit on the top and a unit on the bottom. And if we just write molarity as capital M, There's nothing on the top or the bottom, right? So we always rewrite molar as moles over liters. And now that is in a form where we can use it as a conversion factor. Also take note that that conversion factor contains liters. It does not contain milliliters. So if you are given a volume in milliliters, you're going to convert it into liters. Yes? Two ways of doing that. So for example, if we had 25.0, whoops, I should write that a little further over, 25.0 milliliters, we could move our decimal place 3 places to the left. So we would go 1, 2, 3, and that would become 0.0250 milliliters. If you prefer to use a conversion factor, you could say I have 25.0 milliliters. I need to cancel milliliters and find liters. There are 1,000 milliliters in 1 liter. And so we take 25 divided by 1,000 and we get 0.0250 milliliters. Okay, so either of those methods are fine, whichever you like is good. Oh, that should say liters, because we canceled the milliliters, and so should this one here. Those should not say milliliters, they should say liters here and liters here. My apologies. Okay, so we have a question here. It's all written out for you. I'm going to copy it out over here. How many moles of NaCl are present in 600.0 milliliters of 1.55 molar NaCl solution? So that's the question we're looking at. How many moles? So that right there is our unknown. And the very first thing we're going to do we have to convert, or sorry, we have to rewrite molarity as moles over liters. So what we're going to do is we're going to then take our 1.55 molar is going to then become 1.55 moles per liter. So anytime you have a problem involving milliliters and moles and molarity, you're going to rewrite molarity as moles over liters. Second thing you have to do is, because this is in liters, we don't want the 600 mils to be in milliliters. We're going to have to convert milliliters to liters. So I'm going to take my 600 milliliters. I'm going to move my decimal place 1, 2, 3 places to the left, and we get 0.6000 liters. Now remember, when we're doing conversions, I don't know what's going on out there. Would you mind closing the door? Thank you. We're going to have our unknown is equal to our initial quantity times a conversion factor. Well, we already know that our unknown is some number of moles. Which of these two here, I'm going to highlight them yellow, which of the two yellow things is our initial and which is the conversion factor? Tell your partner, which is the initial and which is the conversion factor? Okay, so this one has 2 units in it, moles and liters, so it is the conversion factor, yes? And that means that this one is our initial quantity, so we're going to have our initial quantity 0.6000 liters times our conversion factor. Now, what unit do we need on the bottom? We need liters, and that means we need to have moles on the top, which means that the 1.55 does indeed go on the top with the mole. And one thing I want you to notice here, the 1 does not go with the mole, okay? So that only applies to conversion factors 1 through 4, okay? And in fact, not even in the mole ratio, because in the mole ratio it could be a 2 to 3 or a 1 to 4, or you know what I mean? Okay, so really mostly for Avogadro's number and molar mass. Really just for Avogadro's number and molar mass. Okay, so we have this. We will cancel those out, and we will do our calculation and get 0.6 times 1.55 equals 0.93. And the only unit we have left is the mole. Are my sig figs looking good? No, no, no. How many sig figs in this 0.6000? There's 4 sig figs. And how many sig figs in 1.55? 3 sig figs. So how many in our final answer? 3 sig figs. So what do we need to do to the 0.93? Add a 0, and our unit then is moles. We're not going to do the second example on that page. It is there, though, if you need to look at it. We're actually going to skip ahead to page 60, okay? And the question is, what volume of 1.25 molar calcium sulfate solution would contain 5 moles of calcium sulfate? What volume? So that is our unknown. What's the unit for our unknown? Liters, so we don't know how many liters. And what should we do with our 1.25 molar? We should rewrite that as 1.25 moles per liter. And then we have a third thing here, which is the 5 moles. So which of these two, the two yellow things, which of the two yellow things is the conversion factor and which is the initial quantity? Yep, that's our conversion factor because we have a unit over a unit, and that means that this one is our initial quantity. So our unknown is equal to the initial times a conversion factor. And that is equal to, so we want to know the number of liters. We are starting with 5.0 moles. And it's important here that you put in your units first, because if you don't put in your units first, people have a tendency to just write down 1.25 moles per liter, and then it's like, oh, and then they're solving it, and then they just get it wrong. Why is it wrong if I do this? The moles don't cancel. So that's why I encourage you to write your units in first. Write down what you need to cancel. What do we need to cancel? Moles. And what are we trying to find? Liters. So we want the liters on the top. Once you have those in, then you can go back to your conversion and say, now where does my 1.25 go? It goes with the mole on the bottom, 1.25 moles, and then liters. If there's no number, I can just write the number 1. Okay, so that's why it's important, write your units in first to prevent mistakes. Okay, moles cancel out. 5 divided by 1.25 is 4. Sig figs. How many sig figs should we have? 2 sig figs. So that's going to be 4.0. And our unit is, the only thing left is liters. So that's our final answer is 4.0 liters. Okay, so you'll be using molarity both right side up and upside down. And if you are not taking Chem 12 next year, you can go ahead and do the following. I'll put it up on the board. Okay. Yes? Huh? No. I decided we don't have time for it, but we'll do it on Thursday. Yes. Yeah. Okay, so homework number 1, you're going to study for your quiz. And so that is pages 52 to 54. Do enough to be ready for the quiz. So you don't have to do them all. Number 2, pages 59 to 60. Numbers 1 and 2. And page 61. Numbers 4 and 5. And then I might as well put up the thing that this is for Chem 12 takers only. And this is dilutions 1. Number 1, 3, 5, and 7. So we are actually going to go to dilutions 1 right now. So Carly, are you taking Chem 12 next year? Then you need one of these. Yeah. So like I said, if you're not planning on doing that, you can go ahead and work on numbers 1 and 2. For the rest of us, we are going to go ahead and do dilutions number 1, which is here. Okay, so the key idea to this, are you guys familiar with diluting something? What do you do when you dilute something? What do you add? Water. So you're just adding water. Are you changing the amount of dissolved stuff? No, you're just adding water. So the moles of the solute stay the same. And that's the key idea to this whole thing. If we're diluting, the moles of solute stay the same. So let us take a look at this little picture here. We have 1 liter. And it contains, let's say that each of these little dots represents 1 mole. How many moles do I have in here? I have 2 moles of dots. Yes? Okay, so what is my concentration then? Right? You remember square brackets. What is my molar concentration of dots? I have 2 moles in 1 liter, which is just 2 molar or 2 moles per liter. Okay? Now, we are going to dilute this by adding 1 liter of water. So now, instead of having 1 liter, how many liters do we have in total? 2 liters. But did we change the number of spots that we have? No, because all we did was add water. So we still have 2 moles. But our concentration, again, is just 2 moles now. It's the moles over the liters. So we have 2 moles over 2 liters. And when we do the division, we get 1 mole per liter or 1 molar. All right, and now I'm going to copy out this question over here. We have 2.0 liters of a 9.0 molar solution of NaCl is diluted to a final volume of 6.0 liters. Sorry, I should have written that as an actual M that looks like an M. And we need to find the new concentration of the NaCl. Step 1. Because the moles before are the same as the moles afterwards, our first step is going to be to find the moles. Of the solute. So in this case, who is the solute? NaCl is the solute. So we want to find the moles of NaCl. That's what we don't know. What information in this question would allow us to find the moles of NaCl? I want you to read through that and show your partner what information in this question will allow us to find moles of NaCl. Well, we have 2 liters, yes. And what should we be doing when we see 9.0 molar? We should be rewriting that as 9.0 moles per liter. If I have moles per liter and I have liters, can I find the moles? Yes. Which of these two is my initial quantity and which is my conversion factor? 2 liters is the initial and 9 moles per liter is the conversion factor. So my unknown, the moles of NaCl, is equal to my initial quantity, 2.0 liters, times the conversion factor. What should I be writing in here? Should I be just going right away and writing 9.0 moles per liter, or should I think a little bit first? I should think, and I should think, where do my units go? Which units do I want on the bottom? Liters. And what unit do I want on the top? Moles. So indeed, in this case, it turns out that I do want moles over liters. So I do want the 9.0 on the top and the 1 liter on the bottom. And that gives me 18, 2 sig figs, liters cancel, and we're left with moles of NaCl. Now we're not done our question because that was just step 1. Step 2, the new concentration is equal to the moles over the new volume. Yes, so it's going to be moles over liters, but it's going to be the new volume because we're looking at the new concentration. So how could we write concentration of NaCl? What notation should we use? Yes, square brackets of NaCl. I'm going to put a subscript new, so I know that this is my new concentration. And because the moles before dilution is the same as the moles after dilution, I still have 18 moles of NaCl. But my new volume, what is my new volume? 6 liters. So this is over 6.0 liters. 18 divided by 6 is 3. But I need to have, whoa, that's no good. I need to have how many sig figs? 2 sig figs because there's 2 and 2. So that's going to be 3.0. And you can either write it as moles per liter, or how else could you write it? 3.0 capital M. How would we say that? 3.0 molar. Okay, so now you have the tools to do this. Okay, and there we are. Unit 4 quizzes. If you're missing any quizzes, they need to be done. done by this Friday, May 12th. Your labs, if you're missing a lab, it needs to be done by this Friday, May 12th, other than this guy who was away because he was very sick. So